Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone to lecture 5 of ITDR1103. This is Alia, and inshallah we will check in this session the second part of lecture 5, which is sequences. We will introduce first what do we mean by a sequence, and then we will have a look on the types of the sequence and how we can express a sequence. To start with, what is a sequence? Let's have an example, and then we will define the sequence from this example. Sequence is something like 2, 4, 6, 8, and so on, or something like 3, 6, 9, 12, and so on. So if you notice, we have numbers that are placed within a comma and it acts with a specific pattern. So if you noticed here, if we add 2 to the first term, then we are moving to the next one, which is 4. 2 plus 2 is 4. Let's again add 2. 4 plus 2 is 6. And 6 plus 2 is 8. The same is here. If you can see here, every time we are adding 3 to the term, so we move to the next term. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12, and so on. So a sequence is a set of elements written in a row, as you can see here. AM plus 1 until AN. The elements are called terms. So the elements of the sequence, which is AM, are in our example here 2, 3. We call them as terms. K is called a subscript or index of AK. What do we mean by K? K is the number you can see here. So this sequence can be written as A1, A2, A3, and so on. So K is the number down here, and it represents the index of a term in a sequence. AM, which is the first term in the sequence, called as initial term, and AN is a final term. And when we spoke about the final term, we are speaking about the finite sequence, which is the sequence that ends. And sometimes we have some infinite sequence where we don't got a final term. So in other words, we can say that a sequence is a characterized regular patterns. Examples: 1, 8, 15, 22, 29, 2, 4, 8, 16, 32, 64, and -3, 5, -7, and 9, and so on. So from here, you can see the difference between 1, 2, and 3. For 2 and 3, the sequence are ended with ellipse or the 3 dots here, while the first one is with 1 dot. And we are using this expression to indicate whether the sequence is finite or infinite. So whenever we saw the 3 dots or the ellipse, then we can see that this is infinite sequence, which means it has a continuous terms. Whenever we saw the 1 dot, that means this is a finite sequence, which is a sequence with a final term. Now, those sequences are following a specific pattern. For example, We can see here that in order to move from the first term to the second, and from the second to the third, and from the third to the fourth, we are adding 7 every time. Let's see the second one. Here, moving from the first to second, second to third, third to fourth, we are multiplying by 2. And the last one, it's quite tricky because you can see here that we have minus, plus, minus, plus. You can stop the video here and try to find the pattern of the last sequence. The way we express a sequence are two. First one is expressing the sequence in terms view, which is something like the examples here. The second type is using the explicit formula to express about a sequence. So explicit or general formula is a rule that shows how the value of AK depends on K. And if you remember at the beginning of this session, we introduce AK and we says that the K or the number under the term is expressing the index of a term. Where is exactly the place of a term in the sequence? Is it in the first term, second term, final term, and so on? So explicit formula is the rule where we show how the value of the term depends on the index. So if we go back to our examples and let's check the explicit formula or the general formula for that examples. We already saw the sequence 1, 8, 15, 22, and 29, and we say that in order to move from one term to the next term, we are adding 7. However, if, for example, I need to find the 8th, do I need to add 7s until 8th or 100, which is the 100th term? To avoid finding the whole sequence in order to find one term, we can use the explicit formula, which is for this following sequence is AK equal to 1 plus 7K. So if we go to 810, it should be equal to 1 plus 7 times 10, which is equal to 1 plus 70, and this is equal to 71. So from the explicit formula, I got that the 10th term of the sequence is equal to 71. Let's check the 100th term of the sequence. So if we got it as 1 plus 7 times 100, and this is equal to 1 plus 700, which is equal to 701. Put in your mind that this is a finite sequence where the explicit formula stops in here, which is the 1, 2, 3, 4, 5, the 5th term. The second sequence, which is infinite and it's continuous, then we can use the explicit formula in order to find any term in the sequence. The last one, which is minus 3, 5, minus 7, has also an explicit formula that says that the term in place K is equal to minus 1 to the power K times 2K plus 1. For example, the 10th term is equal to minus 1 to the power 10 times 2 times 10 plus 1. And this is equal to, in finding the minus, if the power is even, then the minus will go. If the power is odd, then the minus will remain. So minus 1 to the power 10 is equal to 1 times 2 times 10 is 20 plus 1. And this is equal to 21, and so on. So explicit formula is a way to express a sequence, and it actually has the rule that shows how the value of AK depend on K. Right, now let's move to the second part of our session, which is the types of the sequence, and we'll start with the first type, which is the arithmetic progression. The arithmetic progression has a symbol plus, and it has the abbreviation AP, and now we will understand what do we mean by arithmetic progression and why it has the symbol plus and how we can use it. So we'll start with the sequence 3, 7, 11, 15, 90. So we got this example here, which is the sequence 3, 7, 11, 15, 19. If you notice here, we can see that in order to move to the next term, I am adding 4. So 3 plus 4 equal to 7. 7 plus 4 equal to 11. 11 plus 4 equal to 15. And 15 plus 4 equal to 90. Another way to find this is in arithmetic progression, we usually subtract the next term from the first one. So if you can see here, 7 minus 3 equal to, if we have minus here, 7 minus 3 equal to 4. 11 minus 7 equal to 4. 15 minus 11 equal to 4, and so on. This number here, which is formulating our pattern, called as D, which is the common difference. So the common difference in arithmetic progression has the symbol D, where we use to move between the terms in the sequence. Now, how we express any term in the sequence using the explicit formula, we are using the nth term. So an equal to a1 plus n minus 1 d, and this is a formula that you use in every arithmetic progression. An represents the index of the term that we are looking for. A1 is the first term, and n, as we said, is the index. D is the common difference. Let's suppose I'm looking for A6, which is the sixth term of this sequence. I can easily add 4 to the 19. However, if I don't have all these and I need to find A6 and I have A1, then I can use this rule here. So A6 equal to A1 as the first term, which is 3, plus 6 minus 1 times D, which is 4. So here 3 plus 5 times 4, which is equal to 5 times 4 is 20 plus 3, 23. So the sixth term in our sequence equal to 23. Now let's see how we can use the following rule in order to find the A term if we don't have the common difference. Our example here says that in a sequence we have A4, which is the first term, equal to 12. A7, so the seventh term, equal to 21. And A18, which is the 18th term, we need to find it. So this is the unknown, and I've got those information, A4 and A7. Now, if I got the common difference and the first term, I can easily use the following rule to find A18th. However, I have the A4 and the A7 only. So, we will use the following information. If we wrote the sequence in terms, we can see that I have A4, A5, A6, A7. So from A4 to A5, I added the common difference 3 times. See? We add the common difference 3 times. And this is expressing the 7 minus 4, which is the place of the term and the place of the earlier term. So 7 minus 4 equal to 3, which is, as you can see here, 3 times common difference had been added in order to move from A4 to A7. So from the rule, we can see that A7 is equal to A4 plus 3D, which is 3 times added the common difference. Okay, now A7 is equal to 21, A4 is equal to 12, 3, and D is unknown. So from here, we can get the information that D is equal to 21 minus 12 divided by 3, which is equal to 3. So we got the information that D is equal to 3. Now we can use the common difference in 2 ways. The first way, we can use the common difference to find the first term, then we got the 18th term, or we can get the 18th term from the 7th term and the D. So we'll start with the shortest way. We can see that A18 is equal to A7 plus 11D. From where we got the number 11, it is 18 minus 7, as you can see here. So in order to move from A7 to A18, I added 11 common differences. So A18 is equal to A7 21 plus 11 multiplied by D, that we got it here as 3. So A18 is equal to 54. This is the shortest way. However, we can use the other way, which is finding a term, the first term, then we can get the 18th term. So in order to find the a term, we can use the fourth term, which is a to the power 4 is equal to, A4 is equal to A1 plus 4 minus 1D, which is this rule. A4 is equal to 12, A1 is unknown, 4 minus 1 is 3, and D is 3. And this is equal to 12 A1 plus 9, and A1 is equal to 12 minus 9, which is 3. So after getting the A1, we can get A18th. So A18th is equal to A1 plus 18 minus 1 times D. A1 is 3 plus 18 minus 1 is 7 multiplied by D is 3. Plus 3. So if we multiply 17 by 3, this is equal to 3 plus 51, and we got it, as you can see here, 54. So we can either use the shortest way or we can use the longest way here to find the first term. Then we can get any term in our sequence. Progression. Let's suppose we got A and D as real numbers, and we have the sequence A plus D, A plus 2D, A plus n minus 1D, and so on. We call this as a arithmetic progression AP, where A is the first term and D is the common difference, and we use the nth term to find any term in the sequence. Let's see this exercise here. We have two arithmetic progression, and we've got from those two arithmetic progression the two terms. We need to find the next four terms. So A1 equal to 7, A2 equal to 11. From this information, we can find that D is equal to A2 minus A1, which is 11 minus 7 equal to 4. So the common difference is 4. Now I can find A3, A4, A5, and A6. So A3 is equal to A1 plus 3 minus 1 D, which is equal to 7 plus 2 times 4, and this is equal to 15. A4, A1 plus 4 minus 1 D. So A1 is 7, 4 minus 1 is 3, and D is 4. And this is equal to 3 times 4, 12, plus 7, 19. A5, A1 plus 5 minus 1 D. A1 is 7, 5 minus 1 is 4 times 4. And 4 times 4 is 16, plus 7 is 23. Finally, A6 is equal to A1, 6 minus 1 D. A1 is 7, 6 minus 1 is 5, and D 4. And this is equal to 27. So the sequence after finding the next four terms will be like 7, 11, 15, 19, 23, and 27. Is this the only way of finding the next four terms? No, we can have it easier by adding every single time 4 to the term. So here we can add just 4 to 11 and we get 15. 15 plus 4 is 19. 19 plus 4 is 23. 23 plus 4 is 27, and so on. Let's check the second sequence here. The A term, or the first term, is equal to minus a half, and the second term is equal to 1. Let's find D. D is equal to A2 minus A1, which is 1 minus a half. And from here you can find that D is equal to 1.5 or 1.5. So we can find that A3 is equal to A2 plus D, which is 1 plus 1.5, and this is equal to 2.5. A4 plus 1.5 is 4. 4, this is A4. A5 and A6. So A4 plus 1.5 is equal to 5.5, and 5.5 plus 1.5 is equal to 7. So the sequence after finding the next 4 terms is equal to minus 1 over 2, 1, 2, 0.5, 4, 5.5, and 7, and so on. The second type of a sequence that we will learn about today is the geometric progression. The geometric progression has the abbreviation GP, and it basically uses the multiplication as the process of finding the pattern. Let's start with an example of geometric progression. We have here 3, 6, 12, 25. So if you noticed, in order to move from the first term to the second term, we multiplied by 2. Second to the third, we again multiplied by 2. Third to the fourth, multiplied by 2. So we call this as the common ratio. In the common ratio is the number that multiplied by the term to reach the next term. Sometimes it's not so clear as we have in this example, the term. So in order to find it, all what we need to do is just divide the next term from here. So 6 divided by 3 equal to 2. 12 divided by 6 equal to 2. 24 divided by 12 equal to 2. So here we got that 2 is a common ratio, and a common ratio has the abbreviation as R. Now in the geometric progression, we can find any term in the sequence by multiplying the first term to the common ratio to the power n minus 1. Let's suppose I want to find the next term here, which is A6 or A5. Let's go for the A6. So A6 is equal to 3 multiplied by the common ratio, which is 2, to the power 6 minus 1. And this is equal to 3 times 2 to the power 5, which is equal to 3 times 32. And we got it here that the sixth term is equal to 96. Okay, now from the nth term we might get a lot of information. Let's see the example that says that in a GP sequence, we have A3 as 12, a6 as 3 to 4, and we need to find the 10th term. As we did in the arithmetic progression, we will get the use of the nth term rule here in order to find the 10th term. And how we do so? We will get the use of those two information. If we have the sequence as A1, A2, A3, A4, A5, A6, and so on, we can see that from A3 I multiplied by R 1, 2, 3 times. R. So in order to move from A3 to A6, I multiply the term by R 3 times. So we can see that here 6 minus 3, which is the place of the terms, is equal to 3. So we will use the idea of 3 times 3 times 3. So here we got that A6 is equal to A3 multiplied by R to the power 3, which is 3 times 3 by 3 by 3. A6 is equal to 3 to 4. A3 is equal to 12, and R is unknown until now. So how we get the R? We need to isolate R. Then we just divide by 12. So we got here that R cubed is equal to 324 divided by 12, which is equal to 27. Now we take the cube root from both sides, and we got that R is equal to 3. Now we have two ways to find the 8th. Either the shortest way, where 8th is equal to A6 multiplied by R to the power 4. And from where we get 4, we just subtract the index from each other. 10 minus 6 is equal to 4. Now 8th is unknown. A6 is equal to 324 multiplied by R. We got it as 3 to the power 4. And this is equal to 26,244. Or we can use the other way, where we need to find the first term, and then from the first term we can get the 10th term. So A3 is equal to A1 multiplied by R to the power 3 minus 1, and this is equal to A3 has the value 12, A1 is unknown, and 3 we got it as 3 to the power 2. So 12 equal to 3 to the power 2 is 9, so 9 A1. If we divide by 9, we can see that A1 is equal to 12 by 9, which is equal to 4 by 3. So after getting the first term, we can get the 10th term. So here a to the power 10, a10th is equal to A1 multiplied by R to the power 10 minus 1, which is equal to 4 over 3 times 3 to the power 9. So 1 3 can go with 1 3 here, and we left with 4 times 3 to the power 8, and this is equal to 26,244. You can use either this way or this way, it's up to you, and it's up to the question itself. So the geometric progression is basically the sequence AR to the power 2 till AR to the power n minus 1 till AR to the power n, where A and R are real numbers. Geometric progression, A is the first term, R is the common ratio, and we have the nth term. The rule of the nth term is A multiplied by R to the power n minus 1. Let's see this exercise. If we got the nth term of a GP as 20 and 13th term of the same GP as 640, then we need to find the 20th term. We can use the way that we used already. So first we need to find the R. So here we got that A3 is equal to A8 multiplied by R to the power 13 minus 8, 5. So A13 is equal to 640 equal to A8, which is 20, multiplied by R to the power 5. Now 640 equal to, yes, we need to divide by 20 on the both side in order to find R5. So here we got that 32 is equal to R to the power 5. Now we need to find R5, so we got that R is equal to 2. Now A20 is equal to A13 multiplied by R to the power 20 minus 13. So 20 minus 13 is 7. A20 is equal to A13 640 multiplied by R 2 to the power 7. And this is equal to 2 to the power 7. 32 times 2 is 120. So 640 multiply 128, and this is equal to 640. 81,920. So we got that A20 is equal to 81,920. We can use the other way of using the information of A30, A8 to find R, then find A1, then get the A20. Or there's another way you can check in your slides. So, and here we reach the end of today's session, where we introduce a sequence, and we says that a sequence is a characterized pattern where we got the numbers that follow a specific pattern, something like 1 2 3 4 5 6 or 3 9 8 1 and so on. And we saw that they are two types, AP where we use the addition as the main operation, and GP where we use the multiplication as the main operation. In AP, we have something called common difference, and it has the abbreviation as D. In GP, we have something called common ratio, and it has the abbreviation R. In order to find a term in a sequence in AP, we can use the nth term as an is equal to a1 plus n minus 1 d. an is the nth term, a1 is the first term, n is the index, and d is the common difference. In the GP, we use the nth term rule as an is equal to a1 multiplied by r to the power n minus 1, where a1 is the first term and n is the index, and finally the common ratio as the r. And we saw some examples of AP and GP. Thank you guys for listening. Wish you a safe and a happy day. We'll see you inshallah in our next session.